Alright, so as our title states, we are the Polaris Integration Field Testing and Performance Evaluation Team. My name is John Porter. I'm from the University of Idaho originally. I'm a master's student here with the Robotics Institute, and my background is in electrical and computer engineering.
I'm Tom Carlone from WPI, and I'm an RI student in the master's program.
I'm John Anderson, also from WPI, also a master's student in RI.
I'm Brian Koski. I'm a senior here, and my major is mechanical engineering.
Alright, so let's go ahead and just dive right into this. So again, to remind everybody, what is Polaris? Polaris is going to be a prototype lunar rover. It is designed to search the lunar poles for ice. Of course, that is really why this is an important project, and that is the motivation. We need to have a mobile platform that can carry our scientific payload around the lunar poles and search for that ice that is out there.
So with our ultimate goal of field testing and evaluation, we first have to build Polaris. That requires a lot of mechanical assembly, fit up, electronics integration, and software. The current state as of this morning is a picture on the right, and we're in the process of bonding up the middle carbon fiber beam, and that'll be followed by more mechanical assemblies, pressing bearings, testing shaft bits, and really putting together all the mechanisms so it looks like the detailed CAD view you see on the left. Our goal is to get from the picture on the right to the left over the next few weeks so we can get driving and testing.
These are our midterm goals. The first one is to complete the mechanical integration and assembly. 2 is to complete the electronics integration. And then 3 is to demonstrate that the rover can move short range with the joystick. And then 4 is to develop field testing strategies and objectives, and to have short-term goals to help us move along. And then lastly is to assemble the time-lapse video for the blog.
So by the end of the semester, to elaborate on some of those goals that sound like, for example, Brian said we're going to develop a plan for field tests, but we want to actually implement that plan and go out and do those field tests. So by having a plan by the midterm, we should have a good idea of what we actually need to test by the end of the semester, and then we'll have some time to do that. We also want to deliver some documentation from data we get from those field tests that summarize the capabilities. We really want to know what size rocks can you get over, how long does the battery last, what parts of the rover work, what don't work, that type of stuff. And another part of that is to be able to deliver a manual or even just a checklist that makes it so someone else who didn't work on this project would be able to go use the rover in the future. That's really going to ensure the usability of this, and that it'll actually get used when we start integrating these scientific payloads and test those and that type of stuff. We've also been learning a lot of lessons during the assembly process, so we'd like to deliver some documentation at least on how to not make mistakes we made this time when another one of these rovers is built. So there will be some sort of documentation about what we learned and maybe ideas we had that maybe would make it go smoother. And through the field testing, we want to try to get a total of 5 kilometers, not at once, not one field test 5 kilometers, but if you add them all up, we'd like to go 5 kilometers.